Maybe we'll go in the same route so far, right? We have audience questions. Then I have plenty of questions. In fact, such an interesting technology, it leads to several questions to be answered. Anyway, new and emerging, So I have a question from for Mr. Eon. Mr. Tariq Rahim is asking, can Bahrain use seawater for farming as well as agriculture?
Yes, that's a double-edged sword. So on the one side, seawater contains a lot of things you need to remove, and that costs money. So your water becomes expensive, therefore your farming cost becomes expensive. And for that reason, recycled water is the cheapest way for fast production. That doesn't mean you can't produce things that come from the ocean. So seawater aquaponics is a possibility. The growing and breeding sea fish, breeding crustaceans, crab, mussels, and so forth. And there's also a significant market in the world for plants, including algae and so forth, that grow in salt water. So it is possible. It's not the cheapest way of farming, and it does have limitations. But the preference is recycled water because that gives you year-round agriculture.
Your research is and practice so far is on the recycled water, isn't it, in Bahrain? Not on
Correct.
the
It's
seawater at the moment.
a resource that's freely available here that's not used at the moment. So, it's a very easy manageable resource as well.
Right. We have another question from Lamis Qasim. How is it possible to scale aquaphonic and renewable farm? What is the yield of this farm?
Right. To scale it, we use a dome structure because it allows vertical farming. You can make it a dome. We use a 15-meter dome. You can push it up to about 30 meters if you want. You can attach multiple domes to one another. But the benefit of vertical farming is you don't need such a big space. You can use a much smaller space. You can even do it on a rooftop for that matter. So you don't necessarily need land. You can do it in all environments very easily.
Thank you, Mr. Yon. I have another question from my side. That is, so you said not tractor, but to the tech. Let's set off
Yes.
from track. So that means we need a traction to use plowing to do, some kind of transport, anything. Maybe we need to use renewable resources, but tractor is a necessity, not the diesel or not the petrol driven, but maybe traction is necessary at every point of time, isn't it?
Yes and no. Again, if you actually have some of the latest techniques in farming, which is not a very expensive way of farming, but we don't use soil, so you can actually farm in areas where there is no viable soil. But Bahrain has got a problem with that. Many parts of GCC has got a problem with that. You can effectively raise plants out of the soil. For transport, yes, you do need transport. There was a presentation on EV vehicles earlier. But more important, you are effectively, if you do small farms like this, you are probably 2-3 kilometers away from your market. So even to take your produce to market doesn't mean you need a 30-ton truck. That means you either your customers can come to you or you're very close to your outlet. So all that demand for transport and so forth will get reduced in that way. As I say, nothing is perfect, but yeah, it's certainly reducing the demand to have a big tractor. You can probably have a very small, if John Deere maybe comes to the party and make us electric one, then there will be an answer.
Thank you, Ian. There is less water in more, in areas where there is more sun. This is common in the entire world. How do you think this can be benefited? The sun can be benefited too for, for aqua or for water recycling purposes?
Well, you absolutely need, firstly, from a plant perspective, you need a high enough lux figure, a high enough UVB figure effectively to grow things. For especially the Middle East, you have a lot of that. So that makes it possible to grow things. Again, with renewable energy, with recycled water, district cooling, whatever the case might be with renewables, you can control the environment in the likes of a dome and likes of a grow house, and you can grow year round. The likes of the UK, we've got snowfall, ice, Europe, even America, right down to Texas here. That limits you greatly on what you can produce. But in this area, even the winters are summer for other people, and you can keep on producing. So the potential to convert this region to food production is very significant.
Thank you, Mr. Yon. There's a question for Professor Luciano from Lamis Kasim. Can you put floating solar close to the offshore oil rigs in the Gulf? How about raising water levels? How does they impact? What is the shallowest depth that we can, utilize for floating solar?
Um, Putting them next to wind farms or oil rigs is yes. The answer is yes. In fact, we have even simulated what would happen in terms of shading, and it's actually quite minimal because, as you know, wind turbines are quite spaced apart. And actually, the kites that Tobias presented would be even better because we can integrate them on the platforms themselves. In terms of shallow depth, uh, really any depth. However, if you get into water which is too shallow, probably then it would make sense to anchor, to put legs on the platforms. So if you went into very shallow water, I would probably say rather than floating, I would build platforms. We have used 50 meters for, again, for practical purposes because Malta does not have many shallow areas. I know that Bahrain is a different situation, for example, and therefore a design there might be for 20 meters or 25 meters. But yes, it can be very close to shore, it can be in shallow water and very close to wind farms or oil platforms.
Thank you, Professor Luciano. That's good. Now we have your research specifically addresses a particular concern on the floating solar. Your research has been into the floating solar installations. Have you addressed something very specific, improving efficiencies or anything specific to your company's technology?
Yes, it's actually, as I said, one of the patents we're filing is related to cooling. Since you're going to be on a massive sea of water, it makes sense to use it to cool your panels. In Malta, it gets quite hot, as it does in Bahrain. So your panels can be over 60 degrees in summer, especially. So by cooling them, you improve the efficiency enormously, and the annual yield can improve by as much as 10 or even 15%. So we have a patent going on there. Plus, of course, the other option is, as I said, that you could actually rotate your platform to always face south. It takes relatively very little energy to rotate a floating platform. In fact, this has already been done on lakes where the platform rotates to face the sun.
Thank you. This is very interesting to see that you can rotate. This is a technology developed by you, is that, or it has been existing?
The rotation has already been done by an Italian group, actually, on a lake. But on the sea, it would work the same. The only drawback on the sea is you might not be able to use it in winter when the water becomes very, there's a lot of movement. But
Yeah.
for many, many months, at least in Malta, probably even in Bahrain, the water is quite calm. So you would be able to rotate your platform with very little effort.
These floating solar panel, especially because sea is rough and it can damage the floating platforms. So don't you think, is there any harm to the environment?
Well, we're actually thinking the platforms we're designing would be actually built with light concrete. So
Oh,
quite cheap, a technology that's well known. It's used for docks and other things. You could use steel. You could even use recycled plastic to build them. Um, so in reality, the platforms would last for a very, very long time if you maintain them. So you can imagine a case where every few years you might paint them or coat them, but then the rest of the time they would work fine. The platforms we're designing are modular. Each one is about, let's say, 50 square meters. So they're quite large. And the panels would be 1 to 2 meters above seawater. So your only time when the panels might actually get wet is during storms. And if you anchor your panels properly, that should not be a problem.
Thank you, Professor Luciano. There's a question for Mr. Tobias from Ammar Al-Ghashra. What about landing logistics of the kite? How to avoid accidental landings?
That is one of the probably biggest challenges that we have had to overcome. It comes down to the reliability of the autopilot. And we've been flying these kites for, as I said, almost 20 years. And the truth is, in the beginning, in the first years, the kites did crash. We did propulsion systems for vessels, for ships, and the kites crashed into the water. Fortunately, we have a lot of smart people, and they have optimized the autopilot to the extent that with the power system, we have not seen any crash. So the system is under control. From a technical point of view, the autopilot is a computer system that is located in the ground station, and it communicates via various Wi-Fi connections with the pod that is the robot part on the kite. And at every point in time, we know precisely where the kite is, what condition the kite is experiencing, wind direction, wind speed, the flying speed, the flying altitude of the kite. So this is a fully controlled system at every point in time.
That's great. Thank you, Mr. Tobias. Now, it's interesting. There have been several failures. As you know, there are so many startups in this sky, catching power from the kite. And there have been several failures.
Yeah.
I read about many stories. Great that you have been successful in this attempt. I'm sure that will bring in new technology that is very interesting. Probably you have got a ready-made cabinets. You can buy them, and then a containerized product that can be purchased directly and use it straight away. Is that?
We are in serial production mode. So if somebody is interested in buying one, we are ready to dispatch a unit next week, if you like. And we are proud to say that we are the only company in the world that has a serial product, that is not in prototype state anymore. But it's been a long way. It is difficult.
Yeah, there is a question from Professor Abdul Salam Karim Darwish. How much is the largest energy that can be generated by sky sails? And he also puts it, is there, no, that's for Mr. Professor Luciano. That's okay.
The question was energy production?
Each
energy.
Sky sail. Yeah.
Okay. So it obviously very much depends on the local wind situation. On a decent site, we are looking at up to 600 megawatt hours a year with one system. If you combine, obviously you can multiply that, and that is the technology that we have readily available today. We are currently developing a larger system, which we call the megawatt system, which will probably be 6 to 8 times bigger than the current one. And that is the one that will be used for offshore applications. But today, as I said, we're looking at probably 600 megawatt hours per year. And in LCOE, the cost of electricity between probably 10 and 15 euro cents per kilowatt hour produced.
Thank you so much, Professor Luciano and Mr. Tobias, Mr. Yon. Indeed, it's been great presentations and very interesting in respect of the new and emerging technologies. As pointed out by Ion, I think Bahrain should move from getting into more imports than making it localized. And Mr. Tobias said rightfully, world has to change. That's great. We need to move forward and use it, Professor Luciano's new technologies and floating cells, floating sea, PV technologies. Things have to move forward. Certainly, from the land to the sea to the sky, we have learned a lot of things new and emerging so far. Thank you so much. Everybody wants to adopt to these new technologies for sure, and the future is in your hands probably. You don't let the society down. Thank you so much.
Thank you.
That's
Thanks
right.
for having us.
Thanks for having us. Bye.
Thank you. Thank you, ma'am.
Bye.
Over to you, Madam Susanna.
Thank you, Mr. Raghu. Our deep appreciation to the moderator and speakers for an enriching experience. The interesting discussion on innovations that are pushing the frontiers of alternative energy and water recycling, offshore floating solar energy, and sky sails was very informative and interesting. We now have a short break till 1 p.m. Bahrain time. Please take this opportunity to visit the stalls and meet exhibitors in the virtual exhibition. See you back at the auditorium at 1 p.m.